Days. And U of I's physics professor Nadia Mason is joining us today. And Nadia, we are picking up right where we left off last week, and we're talking about this right here. Like,
yes.
That is pretty cool, the superconductor.
Yes, these are superconductors. As you remember, these are these amazing levitating materials. And the first thing I wanted to emphasize this week is that superconductivity is actually a really common property of materials, right? So you see this and it looks like this crazy magic stuff, but really if you took this aluminum can and got it cold enough, it would levitate and superconduct. And so many materials like lead, tin, aluminum will actually have this property.
Okay.
So how does it work? So the way it works is that in most materials have electrons, and the electrons move through the material, and that's what conducts electricity. Right? So let's do a little demo. So you can be the part of the material electrons hit.
Got it.
You stay there. Okay. Yeah, go back there. Yeah, go behind him. Yeah. Okay, so I'm an electron, right?
Okay.
I just don't care about you or anything. I mosey through and I kind of bump into things, and that creates electrical resistance, and I'm not a perfect conductor. But in superconductors, the electrons interact and they're attracted to each other. So now I'm a superconducting electron attracted to Cynthia, paired up, and I don't even see you. I just mosey through, and the two of us move through the material, not interacting with anything else. You can come back now.
That's how
and we
that
become
works.
perfect conductors, and that's how it works. So the electrons interact, pair up, they're perfect conductors. And except superconductors, I actually have a clip of a superconducting flash mob. I don't know if that's on.
You can dial this up here
We
for
have
you.
it's
Well,
okay.
it's on the way, I'm sure.
It's on the way. So what happens in here is you get these perfectly conducting electrons. They go in circuits around this material. They create a magnetic field that expels the magnetic field beneath them.
Okay.
And so like two different poles of a magnet,
Yeah.
they just repel each other and they levitate. The superconductor levitates.
So what is happening right here?
Oh, okay. So the other important thing is this only happens, so the reason you don't see this commonly is that it happens at low temperatures. So this attractive interaction can be disrupted, sort of randomized by heat, by temperature. Just like, things move around faster. So even if I'm really attractive, I'm hot, I'll just kind of go randomly. Right? And so as it gets hot, it stops superconducting.
Gotcha.
But we do tons of research in trying to find and discover a room temperature superconductor. So these have to be pretty low temperature. This has to be 4 degrees above absolute zero to superconduct.
Okay.
But if we could find a room temperature superconductor, you can imagine that we could, have power lines with no resistance, with no heating. We could have trains that levitate. You could do all sorts of really, great things for energy conservation with a room temperature superconductor. And so we're really researching hard to try to discover this. But the one thing I want to say is that was actually the premise of the movie Avatar. I don't know if you
I've definitely seen Avatar.
right. So I don't know if we could. Yeah. So there's a picture of Avatar. Those are the levitating mountains in Avatar. And it turns out the reasons those levitate is because in the premise of the movie is that Earth's energy problems were solved by a room temperature superconductor called unobtainium, and that was only available on the moon Pandora, and they had to mine it there, but Pandora's atmosphere is toxic for humans, that's why they couldn't be there. And these mountains are superconductors, and they're levitating just like our demos there.
Cool.
And that's why the mountains in Avatar levitate. So this is basic science explaining science fiction.
I like that. There's some good dinner conversation for you. Very good. All right, Nadia, thanks so much for joining us this morning. We appreciate it. Hey, make sure you reach out to us on Facebook with your questions that you'd like Nadia or Matt to answer on our segment here on The Morning Show. We'll be right back.